So in this section of the course, we're going to talk about load balancing. Now there are two kinds of load balancers within Microsoft Azure. The load balancer is called a level 4 load balancer, and there's another one called application gateway, which is a level 7 load balancer. Now these have got a lot of things in common, but there are some differences. In this video we'll talk about load balancing, and we'll talk about application gateway after that. Now, what is load balancing? Now, basically, load balancing is the concept where you have traffic that is coming in from another source. So that in this case, it could be the internet, or it could be from another application elsewhere within your Azure network. Traffic is trying to reach one server, but instead of having a single server doing all the work, you've decided to distribute the load across multiple servers, 2 or more servers doing the same job. The load balancer is what does the distribution to ensure that one server doesn't get overwhelmed with all of the traffic. Now in this case, the load balancer, which is the level 4, only makes those determinations based on 5 factors, which are the source IP and port, the destination IP and port, and the protocol. So based on those factors, it can decide which backend pool is going to be the one to send traffic to, and out of those it's going to use an algorithm to distribute the load based on some algorithmic way. Now that means that the load balancer is a fairly dumb device. There's not a lot of intelligence here. It really is just someone comes in the door, sends them to server 1, someone comes in the door, sends them to server 2, someone else comes in the door, sends them to server 3, and that's called a round robin algorithm. There are other ways of handling this. Now so that's one of the benefits of a load balancer, is it basically is able to distribute the traffic that would normally go to a single server into multiple servers. The other benefit is that it is able to detect if something goes wrong with any of these servers and basically drop it out of the rotation. So let's say at some point server 3 stops responding. We send it traffic, and then a timeout happens and it never returns with a response. We can then make the determination after 1 or 2 or more failings that server 3 is dead, and we can basically just cut it out and only send traffic to server 1 and 2. So not only does it distribute the traffic, but it also monitors the health of the recipients and can then cut them out of the rotation when they are no longer healthy. Okay, so that is the primary function of a load balancer. Go into Azure. Under networking, we can see that we have these options. Let's create ourselves a load balancer. Give it a name, AZSJD, new LB, classic name for a load balancer. First decision that we have to make is whether it's a public or a private load balancer, external or internal. Now, a public load balancer has a public IP address and a public name. That means that it's addressable from the open internet. If we made it an internal load balancer, it has a private IP address, does not have a public IP address, and is absolutely not addressable from the open internet. Okay, so if we want a public load balancer, then we need to create a public IP address. So let's give the IP address a name, AZSJD new IP, and we just want a basic address. We do not need a static IP that never changes. We are fine with an IP that will occasionally change because we're going to use the name of the IP address, the domain name essentially, to address it, not the IP address itself. We can optionally choose an IPv6 address. Within Microsoft Azure, the load balancer is one of the few devices that supports IPv6. So if you have an application that you need to work over IPv6 and need an IPv6 address, then you are forced to put a load balancer in front of it. So even if there's only one virtual machine, you would put a load balancer in front of that to be able to create a v6 address. Then the load balancer is going to address translate from the v6 address of the load balancer into the private IP addresses of the machines behind. Use my usual subscription. I created a brand new resource group for this. I call this New York app. So I'm going to create this load balancer as the first resource inside of my New York app resource group, and let's leave it into East US 2. Now, while we're waiting for that load balancer to be created, we did notice that Azure gave us the choice between a basic and a standard load balancer. Okay. Now, their standard load balancer is a relatively new feature set within Azure, and basic is the default, but you can choose standard. Let's look at this web page that shows you the difference. So a basic load balancer supports up to 100 instances behind the scenes, whereas a standard one 10x's that to 1,000. Okay. By the way, this table formatting is a bit skewed, but that's not my fault. Within the standard load balancer, we can address any virtual machine in a virtual network, and it could be a blend of virtual machines, availability sets, and the VMSS scale sets. Whereas for the basic load balancer, you get the choice of a single availability set or a single virtual machine scale set. Okay. It does support HTTPS traffic in load balancing in terms of health probes. I guess if your web app or your website only supports HTTPS traffic, then you are forced to use a standard load balancer. It does have some additional stay alive options for the health probe. It supports the new availability zones. We haven't talked about that yet, but it's another way that applications can be distributed for a high availability scenario. Standard load balancers can support that. Basic load balancers cannot. We've got the ability of Azure Monitor, which is Microsoft's new monitoring dashboard. We can now pull in login events from this load balancer into that. Secure by default, so load balancers, basic load balancers are default open, and you would have to then set up your network security group to shut down traffic to load balancers, whereas you would need whitelisted. It needs to be whitelisted in order for traffic to come in. This is the new thing for a lot of resources, blocked by default, denied by default, as opposed to a few years ago when a lot of things were open by default. Okay. So we can sort of see on this type of page that there's some very advanced things in terms of different outbound rules, basically allowing traffic to be sent outbound based on IP addresses or public prefixes, etc. Okay, management operations are a lot quicker. There's an SLA. The SLA here, remember in virtual machines, the SLA is 2 or more virtual machines, 99.99%, whereas the SLA is on the load balancer itself here. Okay, and the pricing is more complex pricing, whereas basic load balancer is free. So you do have some decisions to make. It pretty much in a production environment, you probably want to pick the standard load balancer, simply because it has an SLA, although you have to investigate the pricing for that.